Great, hi. So in this video, Christopher and I are going to quickly explain a couple of terms which are going to be thrown around quite a lot in the other videos in this series. And in particular, we're going to talk about 4 different languages or methods for rendering, transforming, or querying, or otherwise working with XML text, namely CSS, XPath, XSLT, and XQuery. CSS we're not going to teach as part of this series because we think it's basic enough, and what you really need is just a primer, or a reference material such as something like the various different online schools for looking up individual CSS values and so forth, and more likely you're going to want to edit CSS rather than write a lot of CSS from scratch. XPath and XSLT we are teaching in this series, and XQuery we're not teaching for a slightly different reason, which is that it's in fact quite complex. And although it would potentially be useful, we're at the moment we're teaching a slightly shorter workshop, and it's not impossible that we might do some tuition in XQuery at a later date. But just to put the 4 of those in context, so you know what we're talking about when we use these references in the future. So to start off with, a brief definition of CSS. CSS stands for Cascading Style Sheets. It's basically a set of instructions to a web browser or other display tool on how to style or display HTML. Bearing in mind that HTML is a very specific language within the XML family. It's slightly different from other XML languages in that most parsers of HTML are much more permissive, therefore it doesn't have to be well formed, it doesn't necessarily follow a schema. All sorts of weird elements and attributes can appear in there that aren't formally in the formalization of the language, but that sometimes work in browsers. But basically CSS tells you how to take any XML element and do some sort of styling to it and display it in a certain way. And it's most often used for HTML in web browsers, but it's also used to display XML of other languages in other contexts. It's worth noting also that even when you don't have a CSS file associated with an HTML page, every web browser has its own default CSS that treats certain kinds of elements in certain ways. And I'm just going to give a couple of examples of that as a way of showing what CSS can do. Okay, so if you didn't have any CSS at all, none of these things would happen. So if you find a strong element, which is it's an HTML element, which says, make this this particular word a strong emphasis, which usually means put it in bold. What the browser does is it says, find me a strong element and give it a font weight of bold. In other words, put it in bold. Okay, this is the simplest type of CSS statement. It says, find this strong element and everything that's inside it, print its content. Don't print the element itself, because when you display a web page, elements themselves are invisible, but just print the content of it and put it into bold in this case. Slightly more complex, but still basically the same principle. When you find a P element, which is a paragraph element in HTML, your browser is going to, by default, display it as a block. That is to say, it will start the content of that element on a new line, not immediately following the previous element. And it will also give it margins. It'll give it a top margin and a bottom margin, which, as you say, the first and third in there of roughly 1 character height. And it'll give it left and right margins of 0. So it won't particularly nest the margins. And you can override these, but this is the default CSS that you get. So again, this is the sort of thing that CSS does. It takes an element, it prints its content, and does certain things to that content in terms of how it renders them. Slightly more complex is this example, which uses a selector. So it says find any A element, and A is an element that you use to insert a hypertext link in your HTML, among other things. And you can also use it to insert anchors. This is saying when you find an A element that is a link, in fact, then give it a color, and most browsers will color that in blue by default, and they will also underline it. Some browsers might choose different colors there, but that's just an example. And another slightly more complex example here is something that's called a pseudo selector. I mean, this is saying when you find a queue element, this is not what you should do to the content of the queue element. This is what you should do to this this imaginary entity, which is the space immediately before the queue element. And it's saying replace that space immediately before the queue element with an open quote. And it'll do the same with queue after with a close quote. Okay, so it's this is saying put some text content immediately before or immediately after an element when you find it. So these are the sorts of things. CSS can do other slightly more sophisticated things as well, but these are the basic sorts of things that CSS do. It styles or gives rendering instructions on how to handle, in the case of the examples I've just been showing, HTML, but in other examples, XML of any kind. On to our second term to be defined, Christopher.
Yeah, so what you were just showing, Gabby, is all about presentational features of an HTML page. With XPath, we might be interested in looking at identifying parts of an XML document for presentational purposes, but strictly speaking, we're using XPath instead to go into the XML data and identify parts of it for manipulation of strings, numbers, Boolean values, etc. And it's the kind of building block of accessing content in the XML document for further processing in XSLT, which down the road might include some CSS, of course. But at this stage, it's not as much about presentation, but about analyzing what's in that XML document and processing it further. So we just saw some examples with CSS. Let's have a look at a few examples from XPath just to demonstrate this point. So this first example just says, find all add tags in an XML document. And the next example says, find all add tags that have the attribute place equals above in an XML document. Slightly more complex example here says, find all deletion tags that have a following sibling of an add tag in them. So in this case, we're doing an axis search through the XML tree to try and find out a relationship between one element and another. And in this last example, we're counting add tags that do not have the attribute place equals above. So again, this is far more analytical and focused on the data in the XML rather than what its presentation will look like.
Yeah, XPath is absolutely essential because it's the language that is used by all of the other languages we're describing here, with the exception of CSS, to find the parts of an XML tree that they're going to do something to. The language for defining elements in CSS is not completely unrelated to XPath, but it's not quite the same syntax. But certainly XSLT, which is the next thing we're going to talk about, uses XPath to find elements and other contexts within an XML tree. So XSLT is the Extensible Stylesheet Language for transformations. There are other XSLs, but XSLT is the one that we're interested in. It basically, as I said, gives instructions on how to transform or display or otherwise do things to text, data, and structure in an XML file. And it can be used both to read from an XML file and transform it into something else, and it can be used to transform into XML. And most commonly, it transforms from XML into some other XML schema, such as, well, all the same XML schema. It can be used. I quite often use it to tidy up XML files by transforming it from an XML file in TEI to another XML file in TEI, just with changes in there. But it's very often used also to generate HTML, which, as we've said, is a version of XML. But also things like ODT, which is the language behind the XML language behind OpenOffice documents, which can therefore be saved as Microsoft Word documents. FO, which is formatting objects, which is used to create things like PDFs and other very much print-ready sort of displays of things. Database tables, which often have an XML instance of them, search indexes, and all sorts of things. So you take an XML file, that's a TI XML file in our case, and you can create some other kind of XML from it using XSLT to transform that. So an example of a relatively simple template in an XSLT style sheet follows here. So this is basically saying find the TI element speech wherever it occurs in the document. So, or whenever you find an SP element, it's effectively saying do the following to it. Firstly, put it in a paragraph. Everything that we're doing inside, put inside a paragraph. We're assuming we're transforming to HTML in this case. So you've got a opening paragraph and closing paragraph before and after everything. Then it's saying create a bold element in HTML and put inside the bold element the value of the who attribute of that speech element, and then put in a colon and then a space. And then after you close the bold element, either print the contents or transform in ways that are defined by other templates in this style sheet, anything else you find inside the speech. Okay, so apply templates just means, and then carry on and keep looking. Now, what you'll notice about the way this works, or if you haven't noticed, the way this works is I'm not saying first create this HTML file and then go and find all the speeches and print them in the following order. It's saying go through the XML file, and whenever you find something, see if I've got a template that tells you what to do with it. Okay, and so when you find a speech, you'll see, aha, we've got a template which tells you what to do with it, and this is what you'll do with it. And so it'll do it as many times as it is in the XML file. I don't have to guess how many times it'll be there. It'll do it in whatever order it appears in the XML file. I don't have to say, you know, I need to remember that I'm interspersing speeches and speakers and other things and stage directions. I can just write this template, and whenever it finds a speech, it'll do whatever I've told it to do in this template. So that's how XSLT works. It creates another XML file from your XML file. I mean, it can do other things as well. That's the basic thing it does. In contrast,
right. So you will have noticed in XSLT that you're writing in an XML language. It looks like an XML document, right? Behaves like an XML document in many ways. What XQuery is purely a querying language that's used for collections of XML documents, and it can handle other types of data models too. So one question that you might ask yourself is, why would you use XQuery as opposed to XSLT, especially given the fact that XPath is being used in both XSLT and XQuery to do kinds of searching activities and so on? Well, the answer is a lot of people use both XQuery and XSLT. Some people only use XSLT. In fact, a lot of people do, but some people only use XQuery. So it really, there's no right answer, really. In a lot of cases, when we're talking about programming languages, it depends on your preferences and your particular circumstances and your technical know-how and technical support. But generally speaking, with XQuery, you're dealing with less verbose language than XSLT. And that's because it's a procedural language. XSLT is more of a functional language, which is easily demonstrated by the example we just saw, where you have functions that have things like template matches that then render content through an apply templates instruction. It's functioning like a program, but a lot of what you're seeing in the XSLT is built into these predefined functions that do a lot of work for you without you really knowing it. Whereas procedural markup is very specific instructions about what actions to perform. And that tends to be less verbose when we're dealing with XML documents. Another major difference is that XQuery was designed within a database environment. So technically speaking, you can batch process and batch search using XSLT. But what XQuery can do is say, take a collection of XML documents, put them in an XML database, and then you can select from the XML database any information you'd like using XQuery language. So XQuery is sort of the XML version of SQL, which is the database language that a lot of other people use for other kinds of information. It can be kind of hard to learn and complicated, and we're not going into a lot of details about it, but it's good to know that, as I said, people tend to use both. This is just a quick example where you see you can probably recognize some XPath. We're using a $sign to define a variable and a for loop. But the crucial information here is the word return, which is kind of database language for, give me the results of this XPath search, which is rendered in this case as a for loop. So that just gives you a sense of, like, if you're in an XML database, for example, you'd be smart to use some XQuery to be able to return lots of results from lots of different documents and to perform similar kinds of functions that you do in XSLT, but within a database environment.
Yeah, you make a good point that which you decide to use, XSLT or XQuery, in a particular context depends on a bunch of different things, such as what you're trying to achieve, what the most effective way of doing it is, but also what your own skills are and what the availability of the things are, and what the scale of what you're working with is. If you're working with a single XML file, it's hard to imagine saving any time by doing XQuery rather than XSLT. On the other hand, with a large collection, I would still query a large collection using XSLT, not because I'm going to argue that XSLT is better at doing that than XQuery, because I don't know any XQuery. So I would, that's purely why I would do it. And there would be some things that I probably couldn't do easily, or maybe even at all, that XQuery would allow me to do. But I've that would potentially put me in that situation. By the same token, there are some people who only use XQuery, as you say, because that's the language they know. They don't know or like XSLT, and therefore they're doing something slightly more clunky if what they're trying to do is create a HTML page from an XML file, because they're doing something. They're using a language that's not quite as well designed to do it. They can do it in most cases, just as you can create HTML pages from database records. Using SQL or whatever query language is native to the database, but XSLT is really actually quite slick for doing that. Especially with non-databasey like content, where you don't know what order things are going to be in, you've no idea how long individual things are going to be, how many times they're going to be repeated, all those sorts of things. So there are both cases where one is clearly more effective than the other, but also you'll go with what you know. And some people use neither, right? Some people use R to process all their XML.
I've used R, I've used XSLT, I've used a little bit of XQuery, not a lot. But I'll just give you a practical example that might help people. I've pretty much used XSLT more than anything else, but that's because I'm usually working with small collections of documents. But I have colleagues, and I'm sure you have them too, who've set up ExistDB, which is the Exist database for XML databases, or BaseX is another XML database. But the publishing platform TEI Publisher is built on ExistDB, and it's really smart if you decide to use TEI Publisher to get to know some XQuery, because then you can dump all of your XML into the database ExistDB and query and generate a lot of information and process accordingly. So, in that case, you might want to learn some XQuery. If you're just working with one or two documents, probably not.
Yeah, that's probably true. Yeah, cool. Anyway, so that's an overview of what those 4 different things are. You'll hear a lot more about XPath and XSLT, not so much more about CSS and XQuery, but that's giving you some context as to what they all mean. Cool.
Cheers.
Cheers.